Welcome to Understand the Math. In this video, I'm going to teach you how to graph quadratic functions. We'll start by going over some steps that you can follow, and then we'll walk through 3 example problems step by step so you can see exactly how it's done. I'm going to start by walking you through 6 steps that you can follow to graph any quadratic function. The quadratic function that you'll be graphing looks like f of x is equal to ax squared plus bx plus c. The first step that we're going to do is to determine the direction of the parabola. If a is greater than 0, the parabola opens upward, and then if a is less than 0, the parabola opens downward. In order to check the direction of the parabola, all you have to do is find a and then check if it's greater than or less than 0. The second step is to find the vertex, and I've listed the formula for the vertex here so you'll have it. To find the vertex, all you need to do is use the formula and let x be equal to minus b over 2a, and then plug that back into your equation and find y. The third step is to find the axis of symmetry, and I've listed the formula here. And to find the axis of symmetry, all you have to do is let x be equal to minus b over 2a, which you've already calculated when you found the vertex. Let's go on to the fourth step. The fourth step is to find the y-intercept. Let's go back up to our graph and let's see what this is. The y-intercept is the intercept right here or right here. It's where the curve crosses the y-axis. And at that point, x is going to be equal to 0. Let's go back down here to our step. So in practice, to find the y-intercept, what you're going to do is you're going to set x is equal to 0, and then you're going to find y. Our fifth step is to find the x-intercepts, if any. Let's go back up to our graph once again. These points are the x-intercepts, right here and right here. Let's now see how you can actually find those intercepts. To find the x-intercepts, what you're going to do is you're going to set f of x is equal to 0. So that basically means what you're going to be doing is solving the quadratic equation. And when you solve that equation, you're going to find x. I want to point out that you can determine how many intercepts you have by looking at what's called the discriminant, which is b squared minus 4ac. If it's greater than 0, you have 2 intercepts. If it equals 0, you have 1. And then if it's less than 0, you have no x-intercepts. And I'm actually going to do an example of each one of these so you can see how that works. The last step then is to just plot all the points that you've calculated, the vertex, the y-intercept, the x-intercepts, and then also the axis of symmetry, and then just draw the parabola. Let's now walk through an example. Our first example is going to be to graph f of x is equal to x squared minus 4x plus 3. I've written down the steps to make things easier for us. The first step is to determine the direction of the parabola. In order to do this, we have to look at a. A is the constant that multiplies x squared. So in this problem, our a is equal to 1, and that's greater than 0. So that tells us that our parabola opens upward. Let's now find the vertex. To find the vertex, we're going to let x be equal to minus b over 2a. If we look up at our function that I've highlighted in green, we can see that b is negative 4, so we have minus a negative 4. We have to watch out with those negatives. And we divide it by 2 times a, which is 1. So this is just 4 divided by 2, which is 2. That's the x component of our vertex. Now we need to find the y component. So what we're going to do is we're going to take this value of x and we're going to plug it into our function and get our y value. F of 2 is going to be 2 squared, looking again at the green highlighted function up above, minus 4 times 2 plus 3. This is equal to 4 minus 8 plus 3, which is equal to minus 1. We can now write down that our vertex is equal to our x value, which is 2, and then our y value, which we just found, is -1. The next step is to find the axis of symmetry. We don't really have to do much work for this because we've already found minus b over 2a. So let's just write down the formula. X is minus b divided by 2a. And we've already found that that was equal to 2. So we can just say that our axis of symmetry is x is equal to 2. Let's now find the y-intercept. The y-intercept is where the graph crosses the y-axis, and that happens when x is equal to 0. So we're going to set x is equal to 0 and find out what f is. So f of 0, and I just see that we can't see our function anymore, so I'm going to go ahead and write it down here. Our f of x is equal to x squared minus 4x plus 3. We're going to plug in that x is equal to 0, so we end up with f of 0 is equal to 3, and that tells us that our y-intercept is equal to 0, 3. Now we're going to find the x-intercept. That's the one that always takes a little bit more work. To find the x-intercept, we are going to take our function and set it equal to 0. So what we're going to do is we're going to solve x squared minus 4x plus 3 is equal to 0. This means that we have to solve this quadratic. I have a lot of videos on solving quadratics if you need to review that concept. We have a 1 in front of the x squared, and when this happens, it's usually best to solve the quadratic equation by trial and error. So I'm going to factor this. We'll put an x here, we'll put an x here, set it equal to 0. We need two numbers to multiply to get 3 and add up to get -4. And that's going to be a -1 and a -3. Then we're going to set both of these equal to 0, and we end up with x is equal to 1 or x is equal to 3. Now let's go ahead and write down what our intercepts are. When x is 1, our y is 0, so we have 1, 0, and then our other intercept is 3, 0. Now all we have to do is plot the points and draw the parabola. Let's go back up to the top here and do this. Let's start by putting down the vertex. The vertex is 2 minus 1, so we'll put a circle there for the vertex. The axis of symmetry is x is equal to 2, so let's just draw a dotted line at x is equal to 2. Then our y-intercept is 0, 3, and that's this point right up here. Now we'll go ahead and plot our x-intercepts. And those are 1, 0, and 3, 0. Here's 1, 0, and here's 3, 0. One thing that's really nice about the axis of symmetry is you know that it divides the parabola in half, and each half mirrors each other. So because of that, we can go ahead and add this point right here to make it easier to draw. Now all we have to do is draw our parabola. And I'm going to go ahead and do that. And it looks just like this. And that's it. Let's go on now and do another example. In our second example, we're going to graph the function f of x is equal to minus 2x squared plus 4x minus 2. Just like we did with our first example, we're going to go through our steps. Our first step is to find the direction of the parabola. Our a, in this case, the number that multiplies x squared is -2, and it's less than 0. So we can say that our parabola opens downward. Now let's find the vertex. The x-coordinate of our vertex is x is equal to minus b over 2a. Looking back up at our green highlighted function, our b is 4. It's the number that multiplies x. This gives us a -4 on top, and then 2 times -2 on the bottom because a is -2. And that's just -4 over -4, which is 1. Now we're going to find our y-coordinate. Our y is equal to f of x, and we're going to plug in that x is equal to 1. So looking up at our green function, this gives us a -2 plus 4 minus 2, and that's actually equal to 0. Our vertex then has the coordinates 1, 0. Now we can write down what the axis of symmetry is. That again is x is equal to minus b over 2a. We've already calculated that. Let me go ahead and highlight that. That was right here. So we can just write down that our axis of symmetry is x is equal to 1. We'll now find the y-intercept. To find the y-intercept, we're going to set x is equal to 0. So we have f at 0. And let me go ahead and write down our function again since we can't see it. Our f of x is minus 2x squared plus 4x minus 2. And we're going to substitute in that x is equal to 0, so we end up with minus 2. And that tells us that our y-intercept is 0, minus 2. Now let's find the x-intercepts. To find our x-intercept, what we're going to do is we're going to solve the quadratic equation minus 2x squared plus 4x minus 2 is equal to 0. Right away, you can probably see that we could easily factor out a negative 2, so I'm going to do that. We're going to write this as minus 2, x squared minus 2x plus 1 is equal to 0. And then now we can factor this. There's a 1 in front of the x squared, so we're going to use trial and error. So I'm going to write this as minus 2, and we can write this as an x here, an x here. We have two numbers that need to multiply to get 1 and add up to get negative 2, and that's going to be minus 1, minus 1. So we end up with a repeated root, and that's x is equal to 1. That then tells us that our x-intercept is equal to 1, 0, and we only have 1. Whenever you graph a quadratic function and you only end up with one x-intercept, that means that the vertex sits on the x-axis. So let's go back up here, and I want to highlight that we found that the vertex was equal to 1, 0. So our vertex and our x-intercept are the same thing. Now what we're going to do is plot all the points that we just calculated and draw the parabola. Let's start by graphing our vertex. Our vertex is at the point 1, 0. So we'll put a circle here. Then we can plot the axis of symmetry, which is x is equal to 1. We'll next put down our y-intercept. That is at the point 0, minus 2. And our parabola is going to point downward. So I'm going to use the axis of symmetry and go ahead and put a point over here to the right to make it easier to draw. And our x-intercept is our vertex, so we don't have to draw anything additional. And now we can just go ahead and graph our parabola. Our graph is going to come up like this and then go back down. Let's look at another example. This example is going to be an example where we have no x-intercepts, and I wanted to show you what that looks like. Here's our function that we're going to be graphing. Let's start by determining the direction of the parabola. Our a in this problem is equal to 1, and it's greater than 0, so our parabola opens upward. Now let's go ahead and let's find the vertex. Our formula for the vertex is x is equal to minus b over 2a. Our b is a negative 2, so we have minus a negative 2, all divided by 2 times 1, and that's just 2 divided by 2, which is 1. Now we're going to find the y-coordinate of our vertex, so our y is going to be f at 1. Looking back up at our green highlighted function, we're just going to plug in x is 1. So this is 1 squared minus 2 times 1 plus 2. And this is just equal to 1. Let's now write down that our vertex is equal to 1, 1. Let's now find our axis of symmetry. We never have to do much with that. Let's just write down our formula again. When you write down the formulas as you're working problems, it really helps you memorize them. Our axis of symmetry is then minus b over 2a, which we've already calculated right up here, and it's equal to 1. Now we'll go on and find the y-intercept. I'm going to go ahead and write the function down here again so we can see it. We have f of x is equal to x squared minus 2x plus 2. The y-intercept is where x is equal to 0, so we'll write down x is equal to 0. And then our y is going to be f at 0. Plugging in 0 into our function, we have f of 0 is equal to 2. And that tells us that our y-intercept is the point 0, 2. Now let's find the x-intercepts. To find the x-intercepts, we are going to solve x squared minus 2x plus 2 is equal to 0. This one looks like it's going to be a little bit difficult to factor. Whenever that happens, I think it's helpful to go ahead and calculate the discriminant. I have a video on the discriminant if you need to review that. The discriminant is b squared minus 4ac. Let's see what that's equal to. Our b is negative 2, so we have a minus 2 quantity squared, minus 4, our a is 1, and then our c is 2. This gives us 4 minus 8, and that's equal to negative 4, which is less than 0. Whenever our discriminant is less than 0, we have no real roots. And whenever that happens, we can say that we have no x-intercepts. Now we're down to our last step, and we just have to plot the points and draw the parabola. Let's go back up here and plot our points. We'll start with our vertex. Our vertex is located at 1, 1, and that's right here. Let's next draw our axis of symmetry, which is x is equal to 1. Now let's draw our y-intercept. That's 0, 2. That point is right here. And then let's go ahead and draw a point to the other side. This is where the axis of symmetry is really nice to have. There are no x-intercepts, which makes sense because our parabola opens upward. And now we can just go ahead and graph it. Our parabola comes down like this and then goes back up. And that's it. You've now seen an example where we have a parabola that intersects the x-axis twice, once, and then this one, our parabola never intersected the x-axis. You should now be able to graph any quadratic function.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.